Hey guys, let's understand the another problem of linked list, that is merge to sorted list. Before also we have seen one popular problem of linked list, that is add to number. In this, I have shown you guys how to make a linked list, how the formation of linked list, and some basics of linked list also have covered. You can visit that if you want to know linked list more. And yeah, my video is mostly to the people who already know data structure. You should know what is linked list, then only you will be able to understand this problem in detail and in more proficient way. Okay, so that's what. So let's not waste more time. Let's deep dive to understand this problem. So we will be basically given two sorted linked list 1 and list 2. What we have to do and what we have given. So list 1 and list 2 will be in the sorted form. You can see it will be in ascending order: 1, 2, 4. 1 is less than 2, 2 is less than 4, 1 is less than 3, 3 is less than 4. So this will be in ascending form, this will be in ascending form. We have to combine these two and we have to create one resultant list that should be also in the ascending form, that is sorted. Okay, this is how it will be. At last, we have to return the head of merge list. So we have to return the head of merge list. This is how it is going to be. I think problem is very straightforward and clear to you. So let's move to the IDE. We will see how this is going to behave on the code level. Okay, so how we are going to solve it. So this is the function. This is the final function we will be having. We will be having the list node. We are getting this list node from the main function. The list 1 will be having the value 1, 2, 4. The list 2 will be having 1, 3, 4. So this is being passed to the merge to sorted list. This is this is passed here, merge to sorted list. Okay, we are creating one object. Object is being uh, here we are calling this particular function. Okay, so this function, if you'll see, in this we are passing L1 and L2. We are calling it here. Okay, this L1 and L2 came over here. So this 1, 1, 2, 4 and 1, 3, 4, which will be coming here. So how it will be behaving, I'll show you. On a very high level, we will create one dummy node. We'll create one dummy node. Let me annotate it for you guys. So we will create one dummy node like this. What it says, it will be having 0. And let's keep this as D dummy. Okay. And again, we will create one current. Okay. And that current will be pointing to this dummy. Okay. Now we are having one loop getting created, this while loop. How this while loop will behave, as long as there is some value in L1 and L2, as long as that is lists are not null, this loop will continues. Okay, so what this loop will do, we have some condition inside this loop. We'll see one by one how that condition behaves. So first is like L1 dot value and L2 dot value. So whatever the value which we have, suppose if we have 1 and 1, so this one will this one will get compared to this 1. So L1 value, the first value 1 will get compared to 1. 1 is less than 1. So this will fail. So this will come in the else condition. This condition is not valid. So this will come inside else. Whatever the value we have at the L2, that is 1, that will get to the current next, which we have. So this will be the current next. Inside this current next, what we will keep, 1. And we will move the current to current next. That is what we are doing. So this condition, this particular thing happening for the both L1 and L2. And every time what we are doing, we are moving L1 to L next, so that we can perform the operation on the next element. That's why we are doing this L1 to L next and L2 to L next. This is what. So one is current to current next, just to extend the merged list. And we are moving this L1 and L2 to the next. Don't get confused with so many next. So this is very straightforward. First next L1 dot next is just to move this L1 like list 1 to the next, and here list 2 to the next, and this is moving the merged list to the next. This is the three things we are doing here. Okay, so yeah, let's clear all the drawing. I think if you want to take a screenshot, you can take, and I think you can draw on your copy and understand it more clearly. And at last, what we are doing, if you can see here, right, after the loop ends, after the loop getting end, what we are doing, we are checking if there are any remaining nodes in either of L1 and L2. If there is, it appends to the merged list. That's all. And then we are returning the dummy list. At last, it returns the next node after the dummy node. This this will return the head of the merged list. So this is how it is going to be. Okay, and that this is very simple. And the time complexity also, I think time complexity for this will be order of m plus n. Okay, order of m plus n will be the time complexity for this, and the space complexity will be the constant. Okay, now we will try to understand with let's before that, let me clear all the drawing for you. Let me clear and close it. We will try to understand this with unit test, how this is behaving. I kept a pointer. I am just running in a debugger mode. So how we have the list one as 1, 2, 4, and list two have 1, 3, 4. We need 1, 1, 2, 3, 4, 4. This is how it is going to be, right? So this is our expected output. So we have already ran it. We got 1, 2, 4, and here we got 1, 3, 4. So we'll see how it is going to be. We have already visualized. We will getting created one dummy. Dummy will be having the value 0. The current will be pointing to the dummy node, and this loop continues again, same like I said you, right? One will be getting compared with one. This value will not satisfy, so it will come into the else block. It will come into else, and then the in the current next, whatever the current we have created over here, that is pointing to dummy. To the next, we will keep the L1 value, and that L1 after keeping the L1 value, we will move the L1 pointer to the next, and we will move the current to the current next. Okay, in the very next iteration, again, what we will get, we will get that one getting compared with the next item. So here one will be getting compared with the 3. Okay, so we have seen. So this is how it is going to be. So 1 is less than 3, so it satisfies. So it came inside this. So 1 will be getting appended to the merged list. This current will be moving to the next. So you will see how it is going to be. So 1, 1 came to this. Okay, so now let's move forward. We will get 2 from the list 1, and we will get 3 from the list 2. So 2 is less than 3, that satisfies. So it will come inside this, and it will take that. Okay, yeah. So again, if you will see the next iteration, what we will get L1 as 4 and L2 as 3. So 4 is 4 is less than 3. So it doesn't satisfy. It didn't satisfy. So it will come into the else block, and it will append to the L2 will be getting appended to the merged list. This is the merged list, and merged list will be moving forward to the next, that current dot next. So far so good. Let's move forward. We'll see again what we got. We got 4 left over here, and 4 left over here. 4 is less than 4. This is again the same scenario. We have seen 1 less than 1. So 4 less than 4. It didn't satisfy, so it will come inside this. Whatever the value is left, it will be getting like the 4 will be getting appended from the L2. 4 will be getting appended to the merged list. We'll move L2 to next to but the next is null. We don't have any value inside this. It will come, and you will see we have 4 left in this. Okay, so whatever the left, we have the scenario covered here. So we have null here. So our this particular scenario failed now, right? L1 is not equal to null, and this is end condition, and L2 should also be not equal to 1. So in this, either of 1 is became null. So this loop will be not continuing now. So it will come outside of this. So whatever the remaining nodes left, right? So in L1, we have one value. So that L1 will be getting appended to the merged list. So this is how, and at final, we will be returning this. Okay. We'll be returning this dummy list, which will be something like this: 1, 1, 2, 3, 4, 4. Okay, so this is the final representation of that. I think it makes sense. So it will come here. What is the expected? This is what the expected 1, 1, 2, 3, 4, 4, and that is what we got. So it will satisfy. So the test case passed. So it makes sense to you, right? This is very simple. So just very quickly, we will take this. We'll keep it over here. Okay. We will run this. Okay. Think we got some error. We'll keep one. We'll see. Yeah. Says, okay. Here it is making. Okay. So quickly, let me keep the L1 here. Sorry. So this is actually wherever we have, so we taken list, right? That is one thing we have to change. List list, list list. Very quickly, I will do this list, 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 list. This is what it is, right? And this, it passed, right? So let's submit this. It should take it. The case 1, case 2 scenario should see. We got it. So this is how it is. I'll upload everything, unit test code, blog. I have explained it in a layman language. If you want to understand it, you can go and check it out. The handwritten notes I have not yet updated. Maybe I'll update it. The video will be present here. Okay, so that's all. And I have already told you the time complexity and the space complexity for this will be, time complexity will be order of m plus n, where m is number of element in L1 and n is number of element in L2. And the space complexity will be order of n. Okay. And for extra pointers like current dummy, there will be some more space taken. That is behavior of linked list. Some more space will be taken in the linked list. So that is one disadvantage also. So maybe if I'll make some linked list related dedicated problem, I'll explain you the every details of the linked list. Thank you.